We're in section 2.6, solving equations using multiplication and division. Or division and division, same thing. All right, but before we do that, I just want to do a little bit of review with you over section 2.5. We're going to have two questions. The first one is x plus 15 equals negative 10. The second one will be n minus 8 equals 13. All right, and again, just like we just discussed, we're going to use our two concepts, our fundamental concepts, in order to solve this equation. The first one says use inverse operations, and then that leads straight into our second one, and we do inverse operations so that we can isolate the variable, get it by itself on one side of the equation. So go ahead and solve these two problems. Okay, so on the first equation, what do I do to both sides to solve for x? I need to subtract 15 from both sides. And x equals negative 25. And if I plugged it back in, it is true that negative 25 plus 15 is negative 10. All right, so that's my answer. What do I do for the second problem? I need to add 8 to both sides, and n equals 21. Now, this is getting kind of specific, but I do want to make sure that you're still doing the steps correctly. Did you do the equal bar all the way across? Did you show an addition sign underneath? All right, so it's just those little things that you start to do almost like mental math and you forget to write them. But remember, you have to show each one of those steps. Every year I grade someone's paper that, maybe they showed the addition on the left side but not the right side, and then they forget and they subtract, or they just make those small little mistakes because they're not showing each step. So just make sure that you're still showing all of those symbols. All right, and that's what we learned with addition and subtraction. And today we're basically following those same concepts and those same methods, except now we're dealing with multiplication and division. So if I see a number and a variable together, there's no addition sign, subtraction sign, really there's no sign at all. It's just a number and a variable together. I know that it means what operation? Multiplication. So again, inverse operation says if I'm multiplying, if multiplication is connected to my variable, I must do the opposite, divide both sides by whatever's connected to the variable. That includes the negative. You can't leave the negative with the variable. We cannot have a negative number or a negative attached to our variable. So we must divide both sides by negative 6. All right? And so here, really the most important thing is that we just remember that our rules for multiplying and dividing and how we deal with these negatives. So I'm dividing one negative, that's an odd number, so my answer would be negative 8. All right, now your homework tonight is going to ask you to check. We check the same way that we did in the last lesson, and we do that by taking our value and plugging it back in to the original equation for the variable. But can I just write it like this? I mean, there's no sign in between here, so can I just copy that and just say negative 68? No, because 6 and x means multiplication. Well, when I plug in a number, I have to put it in parentheses to show multiplication now when it's two numbers together. So negative 6 times positive 8, that's one negative, times negative 8. Two negatives multiplied together equal a positive 48, so it does check out. All right, and then we box in our checked answer. Remember, simplify both sides so you can check your answer. All right, so I want you to go ahead and do the second one. You're going to solve and check. When I'm walking around checking your papers, I'm not only looking for the correct answer, I'm looking for your steps. All right, so make sure you show your steps and check your solution. Okay, so we need to divide both sides by 5. X equals 5. Then we plug it back in. And yeah, 5 times 5 is 25. All right, so on its most basic level, all right, this is how we are solving these problems when multiplication is attached to the variable. All right, so guess what example 2 is going to cover? Division, okay? So now division is connected to my variable. 9 equals x over 7 and x over 2 equals 10. So we have division connected to our variable. The inverse of division is multiplication. So I know I must multiply by some number to get x by itself. Well, what's connected to the x? 7. So I have to multiply both sides by 7. Now, it doesn't cancel out to 0. It simply reduces down to 1, but I know that 1x is the same thing as just x, right? Okay, so I don't even have to write the 1. Now I multiply 7 times 9 over here, and what's 7 times 9? 63. All right, so just as a recap, why did I multiply both sides by 7? Why not some other number? Because that's what was connected to the variable. So I didn't multiply both sides by 9 because 9 was not what was connected to the variable. 7 was. All right, so again, I need to check. So I just come down here. 9 equals 63 divided by 7. And what's 63 divided by 7? So 9 equals 9, and it checks out. All right, I'm gonna change up the second one just a tad bit and make 2 negative. Okay, so go ahead and now solve x over negative 2 equals 10. Go ahead and solve for x. So what did you multiply both sides by? 2 or negative 2? So if it's negative, and that's why I added that in, because I just want to make sure that you understand that whatever is attached to a variable, positive, negative, it doesn't matter. You must multiply by that same exact number. And it's not negative 2 over 2. It's negative 2 over 1. If you put it over 2, then you have to cross multiply the 2 and the x, and you're not getting anywhere. Okay, so it's negative 2 over 1 to cancel that out. And now x equals 10? Is that my answer? No, what did I forget to do? I got to multiply the other side by negative 2. What's 10 times negative 2? Negative 20. All right, so checking, I come back and plug it in. Negative 20 divided by negative 2, and does that equal positive 10? Yes. Yes, because 2 negatives is an even number, so it produces a positive answer. 10 equals 10. Checked out. All right, any questions on solving division? Next one is an equation, okay, writing and solving an equation. So let's read this together. I'll read it out loud. It says, one type of thermal ice drill can drill through ice at a rate of 15 feet per minute by using heat to melt the ice. All right, so you guys realize, I mean, ice is almost as strong as concrete when it's frozen solid, okay? So it's a very, very strong product. However, something that will cut through ice really quick is heat. So these drills have special heating components on them to make it much easier to drill through, especially when you have to drill through how much ice? 15 no, feet. How much total? 75 feet of ice. That's a lot of drilling to do. So they use these heating elements. All right, so what I have to do is I have to write and solve an equation. Okay, so I have to write an equation first and then solve it. So every equation has a what? Equal sign. Has an equal sign. Okay, so we're going to go ahead and set up our equal sign. Now remember, the total goes on one side. The combination of our number and variable goes on the other side. I have to figure out what combination is going to work. Well, I can clearly see that what is my total? What is the total amount of ice? 75 feet. So that part should be pretty easy to set up. But now it's the challenge of what combination of another number value that the problem gives me, okay? So what number do you think you're going to use in your equation? 15. 15, because that's how many feet per minute. All right, and then a variable, it doesn't tell me which variable to use. Which one would you choose? F for feet, M for minutes, X, and it does not matter which variable you choose. So now, would you add, and you can, guys, go ahead and write it in. See how it looks to you. Would you add the minutes and feet together to get to your total? Would you subtract the minutes and feet? Would you multiply, divide? What would you do? Okay, so I hear divide. Now, while that is correct to get to your answer, you actually have to multiply, though, the feet and the minutes together to get to your total. However, what do you have to do to get to your answer? You have to divide, okay? So let's go ahead and get our answer, and I'm going to talk about something that I think might help you set up this equation better. All right, so M would equal what, guys?
5 minutes.
5 minutes. That's how long it would take this machine to cut through 75 feet of ice. All right, so when you first read this problem, okay, so you read through it and you say, okay, 75 feet total, it goes 15 feet per minute. What do you immediately think you need to do to get to your answer? You have to divide, right? So in the past, here's what I see on a problem like this. I see 75 divided by 15 equals 5 minutes, right? Here's the problem with that. It's not an equation. However, you did get to the correct answer because you had to divide to answer. So here's my suggestion to you on how to set up this equation. Because I think everybody would agree setting up the equation is the hardest part, right? So you immediately knew you had to divide to get to your answer, right? So that's the inverse operation. If you know, are you listening? If you know that you have to divide to get to your answer, that means your equation has to be multiplying. Does that make sense? Because it's the opposite. So if you know you have to subtract to get to your answer, what does your equation have to have? Addition. You see that? Opposites. Okay, you see how you can kind of backtrack? Because what's not difficult for you is to just kind of, okay, well, I know how to get to the answer, right? But Ms. Kenner, why do I have to set up an equation? Well, because an equation, setting it up is half the battle. Okay, you still have to know how to do that part. So just think, inverse operations. If I have to divide to get to my answer, which a lot of you said that, right? Then that means my equation has to have multiplication. You with me, Daniel? Okay, sit up, please. All right, so hopefully that helps. I know that was kind of a lengthy explanation. One more example and we're done. All right, example 4. What do the instructions say up here next to example 4? Simplify before you solve. So you have a section on your homework tonight where it's not just cut and dry one-step equation. There's actually pieces of the equation that I need to simplify first before I can do my inverse operation. So look at the first one. I want you on your paper, because I think a lot of you probably could get this before I explain it. Go ahead and try to simplify what you think you're going to be asked to simplify. So you see 7x minus 4x equals 24. Can you combine 7x minus 4x? Are they like terms? Yes, they are. What's 7x minus 4x? It's 3x. So we're going to write underneath 3x equals 24, and now I'm back to my one-step equation. What can I do to both sides to solve? Divide by 3. Not 3x, but just 3. X equals 8. And then if this was a homework assignment, you would check. Okay, so just you would still check the same way. Actually, let me show you something. I'm going to need to write this a little smaller. So x equals 8. All right, so for checking, I don't care if you plug it back into this equation or this equation. All right, so it doesn't matter to me as long as I see a substitution. So if you want to go ahead and plug it into the simplified equation, that would be fine. Actually, I'm going to take that back. Why do you think you should still plug it back into the original?
That way, if you solve the original.
Well, think about this. What if you accidentally subtracted wrong here?
Oh.
Then you changed the problem and you got the wrong answer, but because you didn't plug it back into the original problem, you're not going to catch it. So for that reason, technically it doesn't matter, but for that reason, let's use the original problem. So now it's going to be 7 times 8 minus 4 times 8.
So don't even I'm confused.
So on the checking, you're going to plug it back into the very original problem. So since I said my answer was 8, I need to plug it in for x in both terms. Equals 24. Well, put it in your calculator. 7 times 8 minus 4 times 8. 56 minus 32. What would it give us? It gives us 24. All right, so 24 equals 24, and it checks out. All right, so again, use the original problem. You'll just have to make 2 substitutions of your value back into the original problem. And that way, if you made a mistake on step 2, you'll catch it. All right? Look at the next one. Negative 2 equals x over 5 plus 3. On your paper, I want you to try to simplify whatever you think you can simplify first. Before you start solving and using inverse operations, let's see if there's anything we can simplify. What can you simplify?
5 plus 3.
Yeah, 5 plus 3. So now it's negative 2 equals x over 5 plus 3 is 8. So what would I do to solve? I need to multiply. It's already dividing. So I need to multiply both sides by what?
8.
By 8 over 8? Or 8 over 1?
8 over 1.
8 over 1. All right, and now I have to multiply this side by 8 over 1. What's 8 times negative 2?
16.
Negative 16 equals x. And again, when I check, I just plug it back into the original. Negative 16 over 8 is, yes, negative 2. So on your homework, just make sure you show that checking. Any questions? One more problem. Anything? All right, last problem we're going to look at is another simplify before you solve. Negative 2 times 4x equals 40. While there are a couple different ways you can do this, the easiest way is to simplify over here with the variable, if there's something to simplify, before you do inverse operations. So what would be negative 2 times 4?
That'll be 8x.
Negative 8x. It's a funny looking 8. Equals 40. So how would I solve for x?
Divide by negative 8.
You agree?
Yes.
Mara, you agree? Divide both sides by negative 8. Negative 8. And what's my answer? X equals negative 5. And then again, when I solve, or when I check it, I can plug it back into the original. 4 times negative 5 is negative 20, and negative 20 times negative 2 is positive 40. All right, so just checking. And that'll be similar to the last section on your homework tonight. All right, and if you understand that, that's everything you need to know for 2.6.